Hey guys. All right, so let's model the spread of this virus using a table. Although the World Health Organization says that the average person infected with COVID will actually go on to infect two other people, for the purpose of today's lesson, we're going to simplify that a little bit and say that, if I am one person infected with COVID, I'm going to go infect one other person. Okay, so if we start here, couple things. This is actually our y-intercept. I know that sounds a little weird, but this is where we start, right? At 0 days, we'll just say that one person had it. So this is like the very, very, very beginning of the pandemic. One person had it at 0 days. After 1 day, so if you think about this person is going to infect one other person, okay? So now there are two people infected, okay? Because one person infected one other. Okay, now we have two people infected. Well, this person is going to infect one more, right? And this person is going to infect one more. So now on day 2, we have 4 people infected, okay? And so I want you to look at this rule here, right? We could say we were adding 1, right? But that rule doesn't work here because here we added 2, okay? So it's not addition, meaning this cannot be a linear function. So we have to think about, okay, what about multiplication? Well, 1 times 2 gives me 2. 2 times 2 gives me 4. And then I got to think of it logically. If 4 people have it and they're each infecting one other person, right? That's going to give me 8. Well, 4 times 2 actually is 8. All right, so the pattern here is that we're doubling each time. So from 8, it's going to go to 16. From 16, it's going to go to 32. And from 32, it's going to be 64. All right, now I want you to just look at this because this is really important too when we think about why we get that curve from an exponential function. If we're looking at the difference here, right? This day, only one extra person got infected. Okay, well, the next day, we added 2 people. The next day, we added 4 people. The next day, 8 people got infected. The next day, 16 people got infected. And this last day, right, 32 extra people got infected. So if we're looking at in the beginning, right, we were only adding 1 person between days. Okay, it was like a slow rate of change. Now, between day 5 and 6, 32 new people have become infected. All right, so if you think about this being our slope, right, our slope starts not very steep, and then as the days goes on, boom, it gets much, much more steep. Okay. So that was the table. I am just going to have you graph days 0 through 4. If we wanted to change these into ordered pairs, this would be 0, 1. This would be 1, 2, 2, 4, 3, 8, and 4, 16. All right, so when I go ahead and start graphing, I'm going to have my first point here, then here, then I'm jumping up to 4. Now I'm jumping from 4 to 8. Now I'm jumping from 8 all the way up to 16. All right, so you can see here, I'll try to draw this as nice as I possibly can. We have a curve, okay? If you look down here, and this is kind of what I said in that last slide, when we jump from here to here, that's a +1, right? Well, here's a slope of 1. See that? My rise is 1 over my run is 1, okay? When I jump from here to here, it's a +8. All right, and if you look actually from here to here, my rise is now 1, 2, 3, 4, 6, 7, 8 over 1. Okay, so look at how the slopes are changing. We don't have a constant slope in exponential functions. Here we had a slope of 1. I'm going to write this. Right? Here now we have a slope of 8. All right. And that's, again, where we get this curve from. And it just goes to show that from, here, it was much slower. The rate of infection was much slower. Up here, in one day, our slope has gone from, or in this one day, we're getting 8 new people infected. So our slope is much more steep, showing us that the infection rate is much faster. All right. And then last but not least, we looked at the parts of an exponential function on Tuesday, but I wanted to show you this. This is our equation for the model that we just saw with the pandemic, right? We start with one person being infected on day 0. It's the very beginning of the pandemic. Then that one person, right, infects another. And so what happens is the number of people infected doubles, right? Which is where we get this 2. This is really like multiplying by 2, right? Which is what we did in the table. Our input is the number of days in the pandemic, and then our output is the total number of people infected.